Hello, everyone. This is Carmen Vertullo with your Fastener Training Minute, coming to you from beautiful El Cajon, California, where on this day in November it happens to be raining, but it's still beautiful, and the Fastener Training Institute. Today's topic comes from a composite of two previous topics, one having to do with tightening strategies. And as we know, torque is a tightening strategy, angle is a tightening strategy, no strategy at all is a tightening strategy. But when we try to apply a tightening strategy to stainless steel fasteners, especially larger bolts above 1/4 of an inch, it really gets interesting and tricky and very difficult to develop an effective tightening strategy. When we return, I'm going to put those two topics together and help you know how to develop a good tightening strategy for stainless steel bolting.
Thanks, Carmen. This is John Walkman for the Fastener Training Institute, FTI, with an update on our upcoming class schedule. On December 1st, we'll partner with the Industrial Fasteners Institute and offer a new webinar, The Very Basics of Bolted Joint Design. This is our last event of 2022 and ends a very busy and successful year for us. In 2023, we'll bring you some new webinars, starting with a 2-part metric fastener webinar in January, fastener basics in February, and corrosion-resistant fasteners in March. We'll again offer Fastener Training Week classes in Cleveland, Chicago, and Los Angeles. In addition, we're bringing back the original individual day option for gaining your Certified Fastener Specialist certification. In 2023, FTI will also produce full-day training classes at both Fastener Fair in Nashville and the International Fastener Expo in Las Vegas. Fastener Training Institute is your training platform, so let us know what new classes and content you need. We are always looking for sponsors to underwrite classes and programs. And now, back to Carmen.
Quality products, quality service, quality customers. That's 3Q Inc., a fastener distributor unlike any you've worked with before. With its unique remote managed inventory stocking programs, wide array of secondary service offerings, and wholly owned cold forming capability, 3Q Inc. has been supporting fastener distributors since 2008. 3Q offers a wide range of 100% American-made fasteners, including ITW SEMS lock washers, as well as specialty and imported parts. Give 3Q a call today to discuss your needs and experience 3Q quality for yourself. 3Q Inc. www.3q-inc.com.
Well, welcome back, everybody. This is Carmen Vertullo with the Fastener Training Minute. I recently had a project, actually I'm still in it, to help develop good methods for tightening stainless steel structural bolting. Now, technically, at this point in our fastener technology, there is no such thing as stainless steel structural bolting. There are simply stainless steel bolts which are used in structural applications. And we have never developed that technology anywhere near the way we have developed steel structural bolting, such as our ASTM A325s and A490s, and the tension control bolts that go along with those. One of the reasons why stainless steel structural bolting can be such a challenge is stainless steel bolting, like steel bolting, comes in different strengths. And also it has a propensity to gall, which greatly hampers the torque-tension relationship. And like steel structural bolting, the strategy for tightening typically should not or would not be based on torque or torque alone. As you know, if you're familiar with steel structural bolting, we typically would use a strategy such as snug tight plus angle or number of turns or number of degrees of turn. And we could also use a strategy such as the tension control bolt. There is no such thing at this point as stainless steel tension control bolts, not likely to be in the future. Or possibly we would use the direct tension indicating washer. And I don't think there are stainless steel direct tension indicating washers at this point either. So we're kind of stuck with either torque or angle or a combination thereof. Now, what we discovered recently is because stainless steel has such a propensity to gall, that means literally the metal of one component, that is the nut or the threads of the nut, wipes or smears onto the threads of the bolt, and you literally have those two things cold welded together, and you don't always know it. You think your torque is going into tension, but all it's really going into is overcoming that tremendous amount of friction because of galling. And the way we combat that is with some kind of a lubricant or anti-galling or anti-seize compound, most of which work pretty good, but again, not very consistently. So we have to come up with a better strategy. And one of the issues we also have to deal with the stainless steel bolting is the washer. Stainless steel washers are not that hard. In the structural steel applications where we're using steel bolting, we have the advantage of using a hard F436 flat washer. It gives us a very nice bearing surface for the nut to tighten against. The stainless steel standard washers are relatively soft, so they tend to embed long before we reach even the low level of tension that we would have on that bolt. And that consumes energy or friction, thereby hampering our torque-tension relationship. So what the hell do we do? How do we know how to get a decent relationship in our tightening strategy between whatever that is and the final tension on the bolt? Well, I have come to the conclusion that the only reasonable way to do it is with a combination of torque and angle, which, by the way, has also been applied recently in the past several years to the steel structural bolting industry with a tension control type bolt called the TNA, or torque and angle. And the way that product works is an automatic tool tightens the nut to a level of snug tightness based on torque, and then a certain number of degrees of angle, which delivers a specified tension. And we can do that in the stainless steel bolting in a manual method by determining first how much torque it takes to achieve snug tight. But of course, we want to define snug tight. And what we would typically define snug tight is as about 10% of the final tension. And that should always be enough to pull all the plies or whatever you're bolting together into firm contact with one another. So we would put the bolt in our Skidmore, use our lubrication, whatever it's going to be, whatever we use in the test, we should use in the actual assembly, snug that bolt down until we get to 10% of our final tension, which for stainless steel bolting off the shelf is not very high. And I'll just give you an example. For a 3/4 10, the final tension is only 11,000 pounds or 11 kips. That's based on the very low yield strength of that bolt. So we're going to tighten it to 1,000 pounds or 1 kip or 1.1 kip, which unfortunately is very hard to see on the Skidmore because the lowest level you see on the standard structural bolt Skidmore is 2 kips. So we need a smaller tool or we need a load cell of some sort. I use a load cell. And we determine what our snug tight would be. In this case, it turned out to be 25 foot-pounds, gets us to 1,100 pounds or 1.1 kips, 10% of our final torque or final tension. Then we go ahead and tighten the bolt the rest of the way until we reach our final tightening, which is going to be 11 kips, and we measure that angle. And it turns out that is very consistent. Within about 5 or 10 degrees at the most, we can achieve the tension we desire, even with the washer embedding. The washer is still going to embed, the soft washer. The better strategy even might be to use a hardened stainless steel washer, which would then have to be made out of a hardenable stainless steel, such as 17.7 pH or 17.4 pH, which is very compatible with our standard 304 stainless. The 316 stainless, you may not want to mix those two together because you'll lose the advantage of having 316 stainless steel without the 316 stainless steel washer. So once that's done in the structural bolt world, we also want to know or ascertain that the bolt is capable of withstanding a certain amount of over-tightening. So then we go beyond 11 kips, probably another 15, 20%, maybe 25%. In this case, we went up to 16 kips, and we proved that the bolt could be over-tightened by a certain number of degrees or a certain amount of torque, even though torque is not our strategy, it would be degrees, without that hurting the function of the bolt. That is, we don't strip the threads, we don't induce galling, and we don't break the bolt. Doesn't mean we don't yield the bolt. Yielding is okay, but we don't want to end up with a situation where we have over-tightened it and now we've either lost tension or we can't ever get it disassembled or something like that. So that whole strategy is called torque and angle, or T&A. It means something else in another vernacular, but right now we'll just stick with torque and angle. And that is by far the best tightening strategy that we know of today. As a matter of fact, there are automated tools that do it in the aerospace and the medical industry. You can even buy an off-the-shelf torque wrench these days that will give you snug tight with a certain torque and then measure the angle after that. And I think that's the way we're going to be doing it with stainless steel structural bolting. As we go forward and we finish our research, we'll probably have another report on that, or perhaps you might see a magazine article on it soon. Well, I hope you learned something about tightening stainless steel bolting and also about tightening strategies. This has been Carmen Vertullo with the Fastener Training Minute. Thanks for listening.